Absolutely.
Perfect. Welcome, John. I can call you John, right?
Of course. Yep. Absolutely. Yep. Mhm.
Okay, perfect, John. Thank you so much for joining our podcast. Let's talk about data. And it's a pleasure to have you. And we are going to bounce a lot of ideas on a very hot topic nowadays: business transformation with AI-driven data products. It's a lengthy narration sentence, but that's what we want to discuss. But before we
No.
do that, we would love to hear about you. Who are you? I know everybody knows you, but just for my audience, please introduce yourself.
No worries. Well, thank you for having me on this. Yeah, it's a really great topic. Looking forward to discussing it. Yeah. So, my name's Jon Cooke. I've been around sort of the data space probably the last 15 years. Been in the tech space, transformation space for 30 years. It's funny. I was just talking to a colleague of mine saying, basically, I did a computing degree, real-time programming degree back in the 90s, early 1990, and I did my first AI module in 1991. So, yeah, it's been doing, I think technically I've been doing AI for 30 odd years. So, yeah, but also I did a lot of work in banking, risk systems, risk analytics, a lot of heavy data in there as well. Ran data practices and AI practices in places like PwC. Did my first Gen AI project back in 2016 for a large bank. We did a information retrieval system using naive Bayes, not transformers back then. And so, yeah, and then formed Dataception after I left Databricks in 2019. And we've been sort of really concentrating on sort of this nexus between product centric stuff. So I've done a lot of product go lives and kind of taking product to market, data analytics, and business transformation and technology. So sort of sitting in the middle of it. And data products is something we see as being that nexus between business and analytics and product. And also, obviously Gen AI. We do a lot of AI projects with Dataception. We've done about 20 actually AI projects, classic and generative as well. So that's definitely another big part of what we do. So yeah, really exciting time to be in technology again. It's like the fourth big epoch I've been through. Internet and big data and
Oh,
yes, now AI. So yeah, it's a good time to be alive if you're in this space.
yeah, yeah. Thanks for introducing yourself. And yeah, we are in an era. It's a change shift of the era. We are coming out of centralized approach towards
Yeah,
decentralized slash federated ecosystem where data products has become one of the to-go word, right? But it comes with a lot of what you can say, uh, guardrails and constraint, a lot of open items which haven't been discussed
yeah,
yet, things which haven't been matured yet. Gen A is one of the example that this LLM and all those kind of stuff are not meant for structured data, but people want to ask anything and everything from LLM. That's not the case. So
right.
okay, I think it will be a great session because it's an open discussion thing about this
Yep.
business transformation. So how do you let's go with the basic because we both come from data world, as you mentioned. Let's jump onto the centralized first. That how centralized approach where we used to build a data warehouse in 2 years and bottom to up, and how that is different from this one. Let's start from centralized. Yeah.
Yeah, so I mean that's fascinating. So I've been through a lot of centralized um, technology solutions or data solutions. Obviously, I went through the whole Hadoop thing back in whenever that was 12, 15 years ago. Actually managed to get two or three of the Hadoop instances to actually work, which is kind of, I think I'm actually one of the rare people who did that. But it
I
was what
wanted to. Yeah.
there you go. Yeah, exactly. Exactly right. But what's fascinating is, one of the things I found during that whole period, because again, that was it. Data lakes are, ostensibly centralized kind of approaches, and obviously the big selling point was to get all your data in one place, and suddenly magic will happen. Of course, that absolutely didn't. But what was really interesting, even back then, what I found out, I was a slightly used Spark version one. I even built a distributed data mesh solution, which I'll get to in a second, because the data lake didn't work. Because fundamentally, the different use cases. One of the things I found very early on, even in banking, when you're trying to use data with different use cases, you need different engines. Fundamentally, sometimes you need a graph engine, sometimes you need a relational SQL engine, sometimes you need a document, this kind of stuff. And interesting enough, when I did a project for a large kind of regulator back in 2016, And we did a great proposal on a large consultancy, large Big Four consultancy, did a great proposal. And I said, right, Spark's going to be the engine. They wanted lots of different use cases around it. So it's going to have a centralized, got a physically distributed, but a centralized platform. I said, Spark, we're going to use Spark for everything. And the first use case was small data doing self-joins, and Spark completely fell over fundamentally. So it's actually, we need a different engine for that. So that was a real epiphany I had literally about 10 years ago, that you need different tool for different use case and be able to spin up new technology. And I think we still suffer a little bit of that today. The kind of let's get everything in one engine. Let's try and put it all into centralized place, even before we know what we want to do with it. And it's really interesting, as you talked a bit about AI and Gen AI, is when, we've done a lot of AI projects, and especially generative ones as well. Trying to get data into a model is actually quite different than trying to get it into a warehouse. It's you're not worried about the structure of it so much. You're worried about the amount of statistically significant data points in it, and you're trying to look at the output model based on what's going in. So those two things is really kind of where we're coming from. It's like, look at the data when you know where you want to use it for, and then pick the right tool for that job, for that engine. And of course, that fits really nicely into the decentralized piece, which we'll talk about in a minute. But going back to the warehouse, I've seen so many warehouses kind of start off really well, and then over time, more and more use cases get on, and they suddenly become this kind of mission critical system which you can't do anything from, but you can't get data into it because it takes too long, and the model stop breaking fact-to-fact joins and all that sort of stuff, because you're trying to model the world as you know it at the time. And of course, as time goes on, that changes, and so I'm a believer in, I think centralized is not quite the right term. It's basically, let's be able to actually decompose a use case and actually deliver a tech solution, end-to-end tech solution for that use case. Now, whether it's on a physically centralized system that everyone can use with a federated operating model, or it's fully decentralized, as in, other people build their own tech, I'm less ambivalent about, more ambivalent about, but it's really that ability to spin up use cases on the right technology quickly, and especially end-to-end use cases. So, sorry, that was quite a long description about where I am on the centralized debate.
No, which is perfect, right? The item which you have brought in, right? Due to which the whole case started towards decentralized.
Yeah.
Decentralized make all product silos. So Federated comes in the middle, where you have some control in the middle. So yeah, the biggest challenge with centralized work, you want to build a dashboard, give it to IT. IT will say, give me 3 months, right?
Yes, exactly.
Go and talk to warehouse model. Within warehouse, there are multiple things. We used to call it subject area. Now people call it domain, right? The same thing. Right?
Yeah, exactly.
We try to implement into the one enterprise warehouse. You have to look at a lot of things like granularity, join, X, Y, so many things, right? So that used to delay a lot of things. Not to mention that dependency on a single team. Right?
Yeah.
Dependency on a single team, dependency on people if they live, ramp up, all those things were there. Then there's suddenly Gen AI comes actually. Yeah. Just like COVID came and cloud became a norm.
Well, I mean, it was interesting. It has always been there, but it's sort of been bubbling away under the covers, So we did we're using transformers like 4 or 5 years ago, like BERT models, which are very small ones, like 500 million weight models. But obviously, ChatGPT what was it 2022? I think it was, wasn't it?
That's a game changer.
Yeah, exactly right. Threw it into the spotlight. You know what I mean? But it's interesting you talk about this, the centralized team, because that's something I do think has been a bit conflated. There's this concept of a centralized team and a centralized architecture. You see a lot of those two things sort of brought together, and they are quite separate, fundamentally. And I think that's something that's not really talked about enough, because it's the operating model around actually how you get people who own the use case to build their own stuff versus the technology and the way that's used across them. So for instance, public cloud is a great example of a logically centralized solution, physically distributed because it needs to be in different regions. It's all the same. It's all the same UIs. It's all the same things, but you have multiple. It's basically a multi-tenant solution. And I think this is something that's, again, it doesn't get talked about enough. I'm a massive believer in people building their own stuff, going finding their own data, putting that stuff together. But that doesn't necessarily need to be on a physically distributed architecture. Like cloud, So I think there's an interesting point around that.
Yeah, you're absolutely right. Actually, the point you have brought it up, that can be handled by a very mature team, I would say. Because even if you have a data warehouse, centralized data warehouse, if we go a little bit more technical, every
Yeah.
subject area has their own set of tables. And there
Yeah.
are masters tables and there are reference tables. Reference tables are interconnected by all subject areas, but master tables are and transaction tables are for the that subject area. So there can be a segregation, and
Yeah.
you already know that. Again, it yesterday I was discussing with this guy Dallin from UK. So we were
Yeah.
discussing the same thing, right? It's not necessarily that every architecture can serve every organization. No, every organization by itself is different. So once you're creating a data architecture at that point in time, you need to understand, for example, privacy and cost
Yeah.
segregation, two big things, which changes
Yeah.
everything. Whether you need to
Yeah.
decouple the architecture at back end or you
Yeah.
want to couple it together. If it's a global recovery that, hey, CEO will budget everything, then you don't need segregation. You can bring everything. But if you need to recover from every department or LOB or entity, then you need
Yeah.
segregation. So yeah,
Yeah.
it's a lengthy debate. Yeah.
It is, but it's always got. I mean, it is, but in my mind, it shouldn't be because I've lost count of how many solution architectures on data platforms I've done over the years. I mean, like dozens and dozens and dozens. But everyone, of course, going back through of examples, the other day, and everyone starts with a process flow.
Yeah.
When we talk about data or tech or anything, we start with the how does the company want to work fundamentally? What do they want to deliver? To what kind of use cases, how do they want to work, what's the flow, who's involved, and you basically do that. If you do that, then basically the architecture needs to support that. And I think we do suffer in data a little bit of the sort of tail wagging the dog a bit, where we go and this is the architecture. It's like, actually, what's the right, I think, to exactly your point, right? It's different companies require different things. We
Yeah.
work with a lot of insurance companies, for instance, and they're very siloed, and they're siloed because their businesses are quite different. Someone's providing retail insurance versus someone who's providing, insuring ships. It's a completely different business. There's not a lot of crossover there. So is there a real need to kind of bring stuff together? Obviously, there are use cases like ESG and other stuff, but actually they're going to have a very different, operating model than a retail company that's basically has a white shop front and that's all they do, right? So but you've got to start always with the operating model. How's this actually going to work? And then the technology that goes behind it. And I think that's something that I say we in data and tech, especially, we kind of start with the architecture and then try and move it into the operating model. It's got to be really the other way around.
Yeah, because to save cost, we ask data engineers to build data models and data modeling
Yeah.
stuff. So that's what happens, right? They end up doing all kind of shit, right? So same thing coming towards your operating model, right? You are
Yeah.
absolutely right, and I'm on the same page. And I think this what I'm going to say now, this is going to become a mandatory thing, else everything is going to fall apart. What I'm going to say is graph theory and FCO modeling, FCO-IM modeling. The other day I had a podcast with Marco from Netherlands, Norway, I guess.
Right.
So this thing is so beautiful. Like if you
Yeah.
end up creating that, and I think last time we could run away because we had a centralized data model, which was enterprise data model, either it
Yeah.
was Bill and Monk 3NF or Kimball,
Yeah.
dimensional model. It was one place. Now, when we go towards data products, a lot of small data models are going to come.
Exactly right. Yeah.
When
Yeah. Yeah.
those small data models come, where you have to refer, where this come from. Right now, it is coming from functional specification document or a DST Excel where you talk to business, you create user
Yeah.
stories, and you do. It's not going to
Yeah.
work, right? It's
Yeah.
not going to work.
Exactly right.
You need to
Yeah.
refer some graph theory, which you
Yeah.
have talked to the business, and you brought the whole business onto the graph. You
Yeah.
know, it can be
Yeah.
a taxonomy ontologies. That's a separate discussion. But once
Yeah.
you have that, then data products need to refer that. I think that let's go towards that angle as well. How do
Yeah.
you see that business transform? Because this is also business, right?
Yeah. Yeah.
Talk to the business, you create.
Yeah.
Then you will talk to the business, you create a graph, and then rest of your decentralized products is follow that. How do you see
Yeah.
that?
Yeah. So this is exactly what we do. So we have something called a data object graph, a dog. I've been seeing a lot of posts around it. And a data object graph is an orchestration of data products fundamentally, and but it follows an actual business process. And we've got this kind of operating model process called the data product pyramid, which is about actually distilling business requirements, an end-to-end flow as for an outcome